Welcome to our guide on the normal distribution. On the digital SAT, understanding this bell-shaped curve is essential for data analysis. This distribution is perfectly symmetrical, meaning the mean, median, and mode all sit right at the center point. Why do we study this? Because most natural phenomena, like standardized test scores or biological measurements, cluster around an average. Recognizing this pattern allows us to make accurate predictions about a large set of data points. The most important concept is the empirical rule. In a normal distribution, approximately 68% of all data points fall within one standard deviation of the mean. This is the core area where most of your data lives. Expanding further, 95% of data falls within two standard deviations, and a massive 99.7% falls within three. On the SAT, you will often use these specific percentages to calculate the number of items in a range. What if a value doesn't land exactly on a whole standard deviation? We use the z-score. The z-score tells us exactly how many standard deviations a specific value is above or below the mean. A positive z-score means the value is higher than the average, while a negative z-score means it is lower. A z-score of 0 means the value is exactly equal to the mean. This standardizes different sets of data. Visually, the z-score represents the horizontal distance from the center of the curve. It allows us to compare scores from different tests, even if those tests have different point scales or averages. Let's apply this to a sample SAT problem. Suppose a math test has a mean of 500 and a standard deviation of 100. If a student scores a 650, how do we find their relative standing? This means the student scored 1.5 standard deviations above the mean. On the SAT, you might be asked to interpret this distance or use it to find the percentile rank. Let's try one where the value is below the average. If the mean height is 70 inches and the standard deviation is 3, what is the z-score for someone who is 64 inches tall? Subtracting 70 from 64 gives us -6. Dividing by the standard deviation of 3 results in a z-score of -2. This indicates the height is exactly 2 standard deviations below the mean. Z-scores are perfect for comparisons. Is a 90 on a test with an 80 mean better than an 85 on a test with a 70 mean? We can't tell just by looking, we need the standard deviations. By calculating z-scores, we see that test B's score is 3 standard deviations above the mean, while test A's is only 1. Therefore, the score of 85 is actually more impressive in its specific context. To summarize, the mean is your center, the standard deviation measures the spread, and the z-score tells you exactly how many standard deviations any single data point is from that center. Let's test your knowledge. If the mean is 10 and the standard deviation is 2, what is the z-score for a value of 13? Think about the formula we just practiced. The answer is 1.5. You subtract 10 from 13 to get 3, then divide by 2. You are now ready to tackle normal distribution and z-score problems on the digital SAT generated by VisionSolve AI.